Hey everyone, today we are going to do our force and motion investigation foldable. So for today you'll need 2 pieces of paper, a marker, and some scissors. And the first one we are going to start with needs to have 3 holes in the top. It can be a sheet of notebook paper if that's all you have, that will work just fine. And the first thing we're going to do is fold that hot dog style, leaving the holes open so that you can see through them. So hot dog style, leaving the holes open so you can see through them. And then under the first hole, on either side, it doesn't matter, we are going to write the letter A. Under the second hole, we're going to write the letter F. And under the third hole, we're going to write the letter M. So your manipulative should now look like this. For now, we're going to put that one aside, and we'll use that one in just a moment. And next, you're going to take your second sheet of paper, and you're going to fold that one in half, hamburger style, so that you end up with like a book. On half of that paper, we are going to cut some tabs, and we need to end up with 3 tabs, so we are going to cut 2 strips or 2 cuts only in half of it, so that it can open into 3 different sections. So 2 cuts on the front half, so it can open into 3 different sections. So thinking about investigation 1 yesterday, we had a question to answer, and that was, how is force related to acceleration? So on the front of your first tab, we're going to write that question. How is force related to acceleration? So that goes on my first tab. So we're going to rewatch yesterday's investigation, thinking of some observations to answer this question, how is force related to acceleration? Now that we have rewatched that investigation, we need to now think of a relationship between force and acceleration. And we're going to end up writing that on our left side tab. So we're going to write our relationship between force and acceleration. And we notice that if you increased the force, then the acceleration also increased. And vice versa. If you decrease the force, then the acceleration will decrease. So we're going to write that now on our left side tab. So I'm going to write, if I increase the force, then acceleration also increases. So if I increase the force, then the acceleration also increases. You could also say if I decrease the force, then the acceleration also decreases. So make sure you have those written down. Now we're going to bring in our other manipulative that we made, and we're going to talk about acceleration, force, and mass. So for this investigation, our mass is what remained constant. And so the way this manipulative works is if you put a pencil or something through your constant, like the mass, you can see the relationship between your other variables, the acceleration and the force. So our rule was if I increase the force, which means I could move my force up, what do you notice also happens to the acceleration? It also increases. So now we're going to draw that relationship in our right side of our foldable. So on that right side, the one that we still have blank, we're going to write another A, F, and M, keeping them towards the top of the section so that we can write and have some things to write underneath. So another A, F, and M. Again, we said our constant was mass, so we're going to write a C under our mass. And we were looking at the increase or decrease in force. So if we move those up or down, we also have to move our acceleration up or down. So our increase is greater with our acceleration, so we draw a larger arrow for that one. So our mass remained constant. As we were increasing the force, our acceleration also had to increase, just like our other manipulative. So now let's move on to investigation 2. We had a question to answer, which is, how is mass related to acceleration? So I'm going to write that on the front of my foldable again because that's my question. How is mass related to acceleration? So that's now on your second tab on the front of your foldable. And we're going to rewatch investigation 2 from yesterday, remembering to think about some observations and some relationships to answer that question, how is mass related to acceleration? So looking at that investigation, we need to, again, come up with a relationship between mass and acceleration. We're going to write that on our left side foldable. So what I saw was if I increase the mass, then the acceleration will decrease. So if I increase the mass, then the acceleration decreases. Again, I can inverse those and say if I decrease the mass, then the acceleration increases. So I'm writing that on my left side foldable. And I can see that relationship again with my manipulative, because in this investigation, the force remained constant. So I would put my pencil inside the force, or inside the hole above the F. And if I increased the mass, then you can see that the acceleration decreases. And if I decrease the mass, you can see that the acceleration increases. So again, if I move those, keeping my force constant, I can see the change. So I'm going to, on my right side of my foldable, again write an A, an F, and an M. With my force being the constant, so I'll write a C underneath that one. They increase and decrease at the same amount, so our arrows will be increasing and decreasing the same. So my arrow under acceleration and the arrow under mass are the same. Now we're going to look at investigation 3. And our question that we needed to answer for investigation 3 is, how is mass related to force? So I'm going to write that question on the bottom tab of my foldable. So how is mass related to force? So that one goes on the front of the bottom one. And we're going to rewatch investigation 3, remembering those observations and trying to find the relationship between mass and force. Now let's think about that relationship and some of the things that we notice. I notice if I decrease the mass, then the force must also decrease. And I can also do the inverse of that. If I increase the mass, then the force will increase. So you're going to be writing that on the left side tab of your foldable. If I increase the mass, then the force must increase, or if I decrease the mass, then the force must decrease. So again, going back to our other manipulative, this time acceleration is our constant, so we're putting the pencil in the hole above A. And we see as mass increases, force also increases. And as mass decreases, force also decreases. So on your foldable, on the right hand side, we're going to do our A, F, and M again. So A, F, and M. Acceleration was the constant, so we are leaving that one with the C underneath. And then as force, or as mass increases, and this one has a larger arrow, our force will also increase or decrease with our smaller arrow. So make sure you have all of those filled in, and those are our foldables for today. Thank you for watching, and we will see you all tomorrow.